3 days of 9.1, we're going to be working with what are called radical expressions. There's a lot of non-calculator stuff here, a lot of simplifying, a lot of good mental math that'll make you a better math student and a smarter thinker. Okay? Not much story problems involved, not much real life applications, just flat out a lot of math. So here we go. So what's a radical expression? It's just an expression that involves a root. Simplest form. So simplest form is lowest terms. And you kind of have to see it before you understand what lowest terms means. First 10 perfect square numbers. We've covered this before, but they are 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. First 5 perfect cube numbers. There's 1, 8, 27, 64, and 125. So as we get started, I encourage you to pause the video and try some problems on your own, and also understand, maybe play it back a little bit to do some understanding. Okay? But the idea behind it is kind of like when you reduce fractions, you want to be able to pull a number out of the fraction. So if I had the fraction 5/10, it's not in lowest terms, so I'm going to pull out and factor out 5. So that's 5 plus 1, and then 5 times 2, 5 times 1 or 5 times 2, the 5 cancels, and I'm left with 1/2. So we should know how to do that by now. Well, with square roots, let's say I have the square root of 45. I can break apart the 45 as the square root of 9 times the square root of 5. I picked 9. I didn't want to pick 15 and 3. I picked 9 because 9 is one of these numbers. And then when you break down the square root of 9 times the square root of 5, you just have the square root of 9 is 3. So then you write it as 3 root 5. It's kind of weird, but root 5 is in lowest terms. And then the 3 just goes out in front. Okay? So in algebra, through multiplication, you can take numbers and split them apart under a root, or you can put them back together. So watch, there's a lot of mental math. If you're pretty good with mental math and numbers and calculations, it's a pretty easy lesson. If not, then these can be hard, but I just give you the opportunity to use your calculator, and you just have to do a lot of guessing and checking to see if any of these numbers goes into these numbers, okay? So we're going to start with the square root of 12. I'm going to break it apart as the square root of 4 times the square root of 3, because 4 times 3 is 12, and 4 is a perfect square. Square root of 4 is 2, so the answer is 2 root 3. That's about as easy as it gets, okay? So 50, I got to find a number that goes into 50. That's a perfect square, and that number is 25. So I have the negative out in front, doesn't matter, but I'm going to break apart 50 as 25 times root 2. Don't forget your roots. Okay? And root 25 is 5, so negative 5 root 2. And you're done, your final answer. I'll circle them to help visualize that. Okay, root 24. 4 goes into 24, so I'm going to use root 4 times root 6. And then letters, I'm just going to break that apart. We'll talk about that in a minute. G to the 6th. Okay? So I'll just give you a shortcut. The root goes into the power that tells you your simplification. So just take the power and divide it by 2, because that's a square root. So my answer is 2, and then I have g to the 3rd root 6. And that's a hard one for kids, but it's really not that bad. You just take the square root of 4 is 2, and then you take the power and divide it by 2. Cut it in half, okay? Whatever's left goes back under the root. So let's do this one. 16 goes into 48, so I have negative root 16 times 3, so root 3. Now you want to take and find as many even roots as possible. So I'm going to zoom out so I have a little bit more room. There we go, just once. So an even root is possible. So I'm going to take 6 of the h's out. And that leaves me with 1 h left. That's because I counted to 7. You see that? So I'd break it apart as 48 is 16 times 3, and I broke the 7 h's as 6 and 1. Now you pull out everything that's perfect. So I've got the negative. The square root of 16 is 4. And then 6 divided by 2 is 3. So I have 3 h's. And then everything else goes back under the root. There's a 3 and an h. So there. Okay? All right. You kind of get the hang of it the more you do. Root 162, I'm going to break it apart as 81 times root 2 times root f times root g to the 10th. So you can break it apart. And then anything that is perfect can come out. Well, the 81 is perfect. Root 81 is 9. And I've got an even number of g's, so cut 10 in half. That gives me 5 g's out here, and then everything else is back under the root. So 2f. Okay. I'm not a fan of bigger numbers, so you might need a calculator. I'm going to go grab my calculator in a second. I don't know what goes into 512. So I'm going to try some perfect squares to see what goes into 512. So 512 divided by 64 is 8, but 4 goes into 8 as well. So 512 divided by 81? No. 512 divided by 144? No, because 144 is a perfect square. 512 divided by 121? No. So it looks like it should be cut in half maybe, divided by 2. It's 256. Is 256 a perfect square? Okay, so 16. So you have to do some guessing and some checking to see how this works. I'm not a fan of the numbers being this big, but we kind of run out of numbers after a while because it's always the same numbers over and over again. So we're going to break this apart as 256 and 2. So negative 256 root 2. Now I've got 3 x's, so I'm going to use 2 of them under a root and then keep 1 for back under, and then I'm going to use 8 y's under a root and then keep 1 under. So I split all my perfect parts. Okay, so when we said negative 256 is negative 16, square root of x squared is x, y divided by, or 8 divided by 2 is 4, and then everything that's not perfect goes back under. So I have root 2xy. Okay, that's about as tough as we can make it. So I encourage you to pause and try one on your own. That's a lot of work that I'm showing. You should be able to do some mental math with the letters. So watch me do the letters so I don't have to write as much. So I'm going to break that apart as 100 times root 3. And then that's negative 10. Now I'm going to do the letters in my head. Half of 12 is 6, so g to the 6th. Half of 7 is, so if I just take away an h, that's 6, and half of 6 is 3. So I've got 3 h's, but I'll have 1 left over. And the same with the j's. Subtract 1 to get j squared. Square root of j squared is j. And then now everything is back under the root. I've got my 3, but I have an h and a j left because they're odd numbers. So you don't have to write it out as much. And that's your final answer. I should probably circle them for you guys. Final answer, final answer, final answer. I don't know if it's more simple. I've argued that with many teachers. I'm like, we're simplifying it. To me, that looks more complicated. But whatever. Good math. Okay. Adding and subtracting fractions. It's kind of weird that we don't have a sample problem to go off of that's easy, so I will make one up right up here above. Okay, so in order to add fractions, or roots, sorry, in order to add roots, they have to be alike. So if I had 4 root 3 plus 2 root 3, the answer is 6 root 3. So the roots are like variables, because if you had 4x plus 2x, that would be 6x. So the rules for adding radicals is they have to be alike in order to add them, otherwise you can't add them, okay? So we can't add these together because they're not alike. But as you see, I can turn 8 and I can make it in lowest terms. So this is 3 root 4 times root 2 plus 3 root 2. Okay? Square root of 4 is 2. So this is 3 times 2 root 2 plus 3 root 2. 3 times 2 is 6. 6 plus 3 is 9. So my final answer is 9 root 2. Let's try another one. So I'm going to simplify everything into lowest terms. This is 2 root 9 root 2 minus 2 root 4 root 5 minus 2 root 5. Because 4 times 5 is 20, 9 times 2 is 18. You got to be good at mental math in order to do these. If not, then you're stuck doing a lot of calculator work, which is fine. It just takes you a lot longer. Okay? So let's do some mental math. Root 9 is 3. 3 times 2 is 6. So this is 6 root 2. And then root 4 is 2. 2 times 2 is 4. So that's 4 root 5. So minus 4 root 5 minus 2. Oops. Root 5. And I can only combine the root 5. So my answer is 6 root 2 minus 6 root 5. So it's very similar to combining like terms with letters. You just got some mental math to do with your square roots. Okay? All right, so this is 3 root 4 root 3 plus 3 root 9 root 2 plus 2 root 9 root 3. So I'm breaking apart my roots. So 3 times root 4 is 6, so 6 root 3. 3 times 3 is 9, root 2. 2 times 3 is 6, root 3. And so that's 12 root 3 plus 9 root 2. There's no fast way to do this, guys. You just have to be patient and take your time. Multiplying is, it takes a little bit of patience. You have to be able to reduce. But in order to multiply, everything outside gets multiplied and everything under the root gets multiplied. Okay? So 2 root 5, this is called the distributive property. So 2 root 5 times root 6 is 2 root 30, because 5 times 6 is 30. Plus Now these are the outside numbers. 2 times 2 is 4, so that's 4 root 5. Now I can't add those together because they're not alike. Now, root 30 in lowest terms, 4 doesn't go into it, 9 doesn't go into it, 16 doesn't go into it, 25 doesn't go into it, so we're done. Okay, so this one, we have, we could probably simplify this first. So root 5y, parenthesis, root 3 minus, or root 3y minus, that's the square root of 25, root 3y. So root 5y, parenthesis, root 3y minus 5 root 3y. Combine like terms on the inside, 1 minus 4 or 5 is negative 3. So root 5y, parenthesis, negative 4 root 3y. Now we need to multiply. So this is all under a root, so the only thing we multiply is the root parts. So the negative 4 stays, and then the root is 15. 3 times 5 is 15, but that's y times y is y squared. And then we can break down the y squared as a y. So my final answer is negative 4y root 15. Okay? We can FOIL with roots. So root 7 times root 7 is just 7, plus 7 root 3 minus 7, or sorry, that's not right. Start over. 7 plus root 21 minus root 21. A negative times a positive is a negative, and root 3 times root 3 is 3. So the inside roots cancel because a positive and a negative root 21 cancel. 7 minus 3 is 4. So that might be the easiest one so far. 14. So root 3 times 4 is 4 root 3 minus root 3 times root 3 is 3 plus 5 times 4 is 20 minus 5 root 3. Combined by like terms, I can combine the root 3's into negative 1 root 3, and then negative 3 plus 20 is plus 17. 15, root 3 times root 7 is root 21, plus 48 can be broken down as 4 root 3, because the square root of 16 is 4. So I'm going to do 4 root 21 there minus 4 root 3. And then minus 16 root 3. Awesome. So I can combine the 21s. That's 5 root 21. And I can combine those. 4 minus 16 is negative 20 root 3. Yeah, I know these are kind of tough, but there's just a lot of calculations, a lot of multiplying, a lot of adding, a lot of dividing, and just everything on the outside you multiply, everything under the root you multiply, okay? All right, last two is something times itself, so I'm going to get rid of the squared and just do 9 plus root 2. I like foiling, so 9 times 9 is 81, plus 9 root 2 plus 9 root 2 plus root 2 times root 2 is 2. So combine my like terms, 81 plus 2 is 83. And then 9 plus 9 is 18 root 2. Okay. And then 17, I'm going to do times itself. So 2 root 5 minus 4. So here we go. 2 times 2 is 4. Root 5 times root 5 is just 5. So that's 4 times 5. Minus 2 times 4 is 8 root 5. Minus 4 times 2 is 8 root 5. Negative 4 times negative 4 is positive 16. So 4 times 5 is 20, plus 16 is 36, minus 16 root 5. All right, that's our first introductory to radicals. I can see why now that we break this lesson apart, because we still have to do other concepts with radicals. Nice job, guys.